Hello, in this lecture we'll find out the length of tangent x. So, in the drawing we have three circles. This is a big tangent. It is tangent to this circle at point A. It tangent to this circle at point B. And it is tangent to this circle at point C. In addition, we have, this is the common extent point M. For this common extent point M, we have tangent MD. It is tangent to this circle at point D. And the length of this tangent MD is 5 units. In addition, from the same common extent point M, we have tangent ME, that is tangent to this circle at point E. And the length of this tangent ME is 7. And finally, we have also, from the same common extent point M, we have tangent MF, that is tangent to this circle at point F. And our mission is to find out the length of this tangent MF that is equal to x. So we have to find out the value of x. In addition, we know that all those three circles are identical. So first of all, we define the centers of those three circles. We define the center of this circle as P. We define the center of the middle circle, this point, as Q. And we define the center of the circle as point S. And in the next step, we will join points P and D together by a straight line. So point P is the center of this circle, point D is a point on the circle itself, therefore PD is the radius of this circle. We define the radius of this circle as R, and because of the fact that all those three circles are identical to each other, all the radii of these circles will be also equal to R. Okay, and here we can implement all one because of the fact that the radius PD is equal to R. The radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever you have radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees, only to move 1. Likewise, we join points Q and E together by a straight line. QE is of course the radius of this middle circle, that is also equal to R. Again, because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this middle circle, and whenever you have radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. And finally, we connect points S and F together by a straight line. SF is of course the radius of this circle that is equal to R. Again, according to rule 1, because of the fact that the radius SF is drawn to point F, that is the point of tendency of tangent MF with this circle, and whenever your radius is drawn to the point of tendency, then tangent MF will be perpendicular to the radius FS. If MF is perpendicular to FS, it means that this angle equals to 90 degrees according to rule 1. Okay. So in the next step, we'll join points M and P together by a straight line. By joining points M and P, we created the right triangle MDP. Likewise, we will join points M and Q together by a straight line. So here we create the right triangle MQE. And finally, we join points M and S together by a straight line. So by joining points M and S, we create the right big triangle MFS. So in the next step, we will implement the Pythagoras theorem on those three triangles. Triangle MDP, triangle MQE, and this triangle MFS. So according to the Pythagoras theorem, in this right triangle, actually according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP square. So MP square equals to PD square plus MD square. Okay, again, according to the Pythagoras theorem, in the right triangle MDP, MP square, that is the square of the hypotenuse, equals to PD square plus MD square. MP is the missing hypotenuse, so here it is. It will be MP square equals to PD square. PD is R, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 squared, that is 25. So in total, according to equation 1, we found out that MP square equals to R square plus 25. Likewise, we implement the Pythagoras theorem on this right middle triangle MQE. This right middle triangle MQE, according to the Pythagoras theorem, MQ square, that is the square of the hypotenuse, equals to QE square plus ME square. It again, according to the Pythagoras theorem, in the right middle triangle MQE, MQ square, that is the square of the hypotenuse, equals to QE square plus ME square. MQ is the missing side, so leave it as it is. And MQ square equals to QE square. QE is R, therefore QE square is R square plus ME square. ME is 7, therefore ME square is 7 squared, that is 49. So in total, according to equation 2, we found out that MQ square equals to R square plus 49. And finally, we implement the Pythagoras theorem on this right big triangle MSF. According to the Pythagoras theorem, in this right triangle, the right big triangle MSF, MS square, that is the square of the hypotenuse, is equal to SF square plus FM square. So if it again, according to the Pythagoras theorem, in the right big triangle MSF, MS square equals to SF square plus FM square. MS is the missing side, so we leave it as it is. So it is MS square, that is equal to SF square. SF is R, therefore SF square is R square plus MF square or FM square. FM is X, therefore FM square is X square. So in total, according to equation 3, we can find out that MS square equals to R square plus X square. So there are 3 different equations for those 3 right triangles. So we note that the distance of those 3 centers PQ and S from the straight line ABC is equal. The distance is of course the radius R. And because of the fact that those 3 points P, Q, and S are located on the same distance from other straight line, they must be also located on a straight line. Again, because of the fact that those 3 points P, Q, and S are all located from the same distance from the straight line ABC, they must be themselves located on one straight line. Therefore, PQS is one straight line. Again, PQS is one straight line according to the rule that I mentioned. So PQS is one straight line. Moreover, the straight line PQS must be parallel to the straight line ABC. Why? Because of the fact that those 3 points P, Q, and S are located on the same distance. They have the same distance from the straight line ABC, and therefore, in total, the straight line PQS must be parallel to the straight line ABC. Okay. So in the next step, we'll join points S and C together by a straight line. Point S is the center of the circle. Point C is the point on the circle itself. Therefore, SC is the radius of this circle, that is R. And because of the fact that the radius SC is equal to R, the radius SC is drawn to point C, that is the point of tendency of this big tangent with this circle. Therefore, whenever you have a radius that is drawn to the point of tendency, then this big tangent will be perpendicular to the radius CS. If this big tangent is perpendicular to the radius CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q and B together by a straight line. QB is of course the radius of this circle that is equal to R, and again, according to the same rule, rule 1, because of the fact that the radius QB is drawn to point B, that is the point of tendency of this big tangent with this circle, whenever your radius is drawn to the point of tendency, then this big tangent will be perpendicular to the radius BO. If this big tangent is perpendicular to BO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to the same rule, rule 1. Likewise, we join points P and A together by a straight line. Again, PA is of course the radius of this circle that is equal to R. And because of the fact that the radius PA is drawn to point A, this is the point of tendency of this big tangent with this circle. Whenever your radius is drawn to the point of tendency, then this big tangent will be perpendicular to the radius AP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. As I already mentioned before, the straight line PQS is parallel to the straight line ABC. Again, the straight line PQS is parallel to the straight line ABC. So here we can implement rule 17. I'll repeat quickly on rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So in the drawing we have two parallel lines, that is to say, this is line A that is parallel to this line B, and we have this is line C that it intersects with those two parallel lines A and B. The points of intersections are those 2 points. So those two angles 2 and 1 are located between the parallel lines A and B, and therefore they are defined as in interior angles. And because of the fact that those two angles, that is to say 1 and 2, they are both located on the same side of this straight line C, that is to say on the right side of this straight line C, they are also defined as one-sided. So in total, those two angles, they are defined as one-sided interior angles. And according to this rule, rule 1, the sum of two one-sided interior angles is equal to 180 degrees. That is to say, those two one-sided interior angles, the sum of them is equal to 180 degrees. That is to say, angle 2 plus angle 1 in total they are equal to 100. The sum of them is equal to 180 degrees. Likewise, those two angles alpha and beta are also defined as one-sided interior angles. And according to this rule, rule 17, the sum of those two angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. So we can actually implement rule 17 in our drawing. Why? Because in our drawing, those two angles are defined as one-sided interior angles, and according to rule 17, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus the size of this missing angle, in total they must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. Likewise, those two angles also defined as one-sided interior angles, and according to rule 17, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus this missing angle must be equal to 90 degrees, to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. According to the sum rule, this missing angle must be equal to 90 degrees, and according to the sum rule, this missing angle must be equal to 90 degrees. Because this angle is 90 degrees plus this missing angle, in total they must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So actually, inside quadrangle POBA, inside this quadrangle we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be at its left angle plus a square. So we relate to this quadrangle POBA as a left angle because it has 4 right angles. So I write it down. This is a left angle, quadrangle PQBA is a left angle, but we also know that the opposite sides of a left angle are equal to each other. So left angle BQBA, side AB must be equal to the opposite side PQ. But AB is 3, therefore PQ must be also equal to 3 units in its length. Likewise, according to the sum rule, actually here we have quadrangle QSCB. Inside this quadrangle we have 4 right angles, and therefore, according to rule 5, it must be a left angle. And according to the rule that the opposite sides of an angle are equal to each other, so left angle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore QS must be also equal to 3 units in its length. Okay, so in the next step, I'll present to you a new rule, and we will implement the new rule in our drawing. The new rule is about the formula of median. Okay, so the rule is about the length of median of a triangle. Okay, so according to the new rule, first of all, what is a median? A median of a triangle is a line segment from a vertex to the midpoint of the opposite side. So if we focus on this vertex A, from this vertex A we have line segment AD. That is to say, line segment AD is located on the opposite side of this vertex A. So, and line segment AD is defined as a median. Why? Because of the fact that line segment AD bisects side BC. That is to say, line segment AD divides side BC into two halves. Each half equals to BC over 2. The first half is BD and the second half is DC. And of course BD equals to DC equals to BC over 2. Okay, BD equals to DC. So what is the length of the median AD? According to this formula, the length of median AD is equal to, first of all, this is triangle ABC, and in this triangle ABC, side AB equals to B units in its length, side AC equals to C units in its length, and side BC equals to A units in its length. So what is the median, the length of the median AD? According to this formula, the length of median AD equals to the square root of 2b squared, which is the length of AB, plus 2c squared, c is the length of AC, minus a squared. A is the length of side BC of this triangle ABC. So total, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared. So can I implement this new rule in our drawing? Well, in our drawing, we know that from this vertex M of the big triangle PMS, this is the big triangle PMS, and from the vertex M we have line segment MQ that bisects chord PS. That is to say, the median MQ divides side PS into two halves. Each half equals to 3 units. PQ equals to 3 and QS equals to 3. So actually MQ is defined as a median because it bisects side PS. That is to say, it divides side PS into two halves. Each half equals to 3 units in its length. So here we can implement the new formula for the length of this median MQ. So according to the new formula, the length of the median MQ, it will be equal to 1 over 2 times the square root of 2 times MP squared, 2 times MP squared, plus inside the root we will have 2 times MS squared, minus PS squared, minus PS squared. So according to the new rule, the length of this median MQ is equal to the square root of actually MQ equals to 1 over 2 times the square root of 2 times MP squared plus 2 times MS squared minus PS squared. So the length of MQ equal to 1 over 2, and inside the root we have 2 times mp squared. mp squared equals to r squared plus 25. So we can substitute mp squared by r squared plus 25. Plus 2 times ms squared. ms squared, according to this equation 2, equals to r squared plus x squared. So we substitute ms squared in this equation by r squared plus x squared. Minus ps squared. Minus ps squared. So ps in total equals to 3 plus 3, that is 6. If ps equals to 6, ps squared must be equal to 6 squared, that is 36. So ps squared in total is 36. So we substitute ps squared in this equation by 36. So in total we should find out that mq equals to 1 over 2 times square root of 2 times r squared plus 25 plus 2 times r squared plus x squared minus 36. Here we multiply this equation by 2 and we get that 2 times mq equals to the square root of 2 times r squared plus 25 plus 2 times r squared plus x squared minus 36. So here we will square both sides of this equation. Two times mq squared is 2 squared, that is 4 times mq squared. If we square this side, the square will cancel the root, and we left only with 2 times r squared plus 25 plus 2 times r squared plus x squared. So here we will open the brackets on this side of the equation and we get that 4 times mq squared equals to 2 times r squared is 2r squared plus 2 times 25 is 50 plus 2 times r squared is 2r squared plus 2x squared. Actually, mq square equals to r squared plus 49. Therefore, we substitute mq squared in here by r squared plus 49. And you get that 4 times mq squared is r squared plus 49. And it is equal to 2 r squared plus 2r squared is 4r squared plus 50. Here we have also minus 36. I forgot minus 36. So it is minus 36. Here we open the brackets and we get that 4r squared plus 4 times 49 is 196, and it is equal to 4r squared, and 50 minus 36 is 14. So in total, according to the new rule that I mentioned, that we found out that 4 times r squared equals to 196, 4 times r squared plus 196 equals to 4r squared plus 14. We have 4r squared on both sides of the equation, so 4r squared will get cancelled. Okay. Here we have also 2x squared, of course. 2x squared. So here we have also plus 2x squared that I forgot to copy it from here. So in total we found out that 196 equals to 14 plus 2x squared. So here we subtract 14 from this equation and we get that 196 minus 14 is 182. So 182 equals to 2x squared. Here we divide this equation by 2 and when we get that x squared equals to 182 over 2 is 91. So here we take a root out of this equation and when we get that x equals to the square root of 91, in terms of numbers, the square root of 91 is 9.54 units. So if we found out that so this question, the length of this line segment MF, this is the line segment MF, that is equal to x. MF that is equal to x is equal to either square root of 91 units, or in terms of numbers it is equal to 9.54 units. Actually it looks very logical because here the distance between point M and D is 5, the distance between point M and E is 7, and it is very clear that the distance between point M and point F must be longer than 7. So it is a little bit longer than 7, it is actually 9.54 units. So x equals to 9.54 units, or the square root of 91 units. So in the next step I will summarize the lecture. So in this lecture, our mission is to find out the length of this tangent MF is equal to x, to find out the value of x. So in the drawing we have two circles, and we have here the big tangent that is tangent to this circle at point A, the big tangent is tangent to this circle at point B, and it is tangent to this circle at point C. In addition, we have this is the common external point M. For this common external point F, we have tangent MD that is tangent to this circle at point D, and the length of tangent MD is 5 units. In addition, we have also from the same common external point M, tangent ME that is tangent to this circle at point E, and the length of this tangent ME is 7 units. And finally, from the same common external point M, we have also tangent MF that is tangent to this circle at point F, and our mission is to find out the length of this tangent MF that is equal to x. Our mission is to find out the value of x. So first of all, we define the center of this circle is P, the center of this circle is Q, and the center of this circle is S. We defined, because of the fact that those three circles are identical, they must have also the same radius. So PA is the radius of this circle that is R, therefore all those radii must be also equal to R because those circles are identical. And here we have we join points P and D together by straight line. PD is the radius of this circle, and because of the fact that the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever your radius is 1 to the point of tendency, then tangent BD will be perpendicular to the radius MD. That is to say, this angle equals to 90 degrees. According to the sum rule, we have the radius PA, that is 1 to point A, therefore according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and E together by straight line. O is the radius of this circle, is equals to R. The radius OE is 1 to point E, and therefore according to rule 1, this angle equals to 90 degrees. We join points S and F together by straight line. SF is also the radius of this circle, that is R. And according to rule 1, because of the fact that the radius SF is 1 to point F, therefore tangent MF will be perpendicular to the radius FS. That is to say, this angle equals to 90 degrees. Here also SC is the radius, and because of the fact that the radius SC is equal to R is 1 to point C, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, the radius OB that is equal to R is 1 to point V, that is the point of tendency of this big tangent with this circle, the middle circle, and whenever your radius is 1 to the point of tendency, then the big tangent will be perpendicular to the radius BO. This is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule, rule 1. Actually, because of the fact that those 3 points P, Q, and S are located at the same distance from this straight line ABC, the distance between those 3 points P, Q, and S from this straight line ABC is of course R. It is the radius of this circle. Therefore, those 3 points must be located on one straight line. Therefore, PQS is one straight line, and moreover, the straight line PQS must be parallel to the straight line ABC. Why? Because of the fact that the 3 points P, Q, and S are located at the same distance from this straight line ABC. So, if we found out that the straight line PQS is parallel to the straight line ABC. So here we can implement rule 17. I'll repeat it quickly on rule 17. According to rule 17, the sum of one-sided interior angles between two parallel lines is equal to 180 degrees. So here we have here two parallel lines. This is to say, line A is parallel to line B, and this line C intersects with these two parallel lines at those 2 points. And here we have two one-sided interior angles. So the sum of those two one-sided interior angles that are located between the two parallel lines A and B, the sum of those two angles must be equal to 180 degrees. Likewise, those two angles alpha and beta are also defined as one-sided interior angles, and according to this rule, rule 17, the sum of those two angles must be equal to 180 degrees. That is to say, alpha plus beta is equal to 180 degrees. We can definitely implement rule 17 in our drawing. Why? Because we already found out that the straight line PQS is parallel to the straight line ABC. So those two angles are located between the two parallel lines PQS and ABC, and they are defined as one-sided interior angles. Therefore, the sum of those two angles must be equal to 180 degrees according to rule 17. So, which angles we have here? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. The sum rule is true here. The sum of those two angles must be equal to 180 degrees. This angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees according to rule 17. The same thing is true here. The missing angle must be equal to 90 degrees, and the same rule 17, can be applied here. This angle equals to 90 degrees. So 90 degrees plus this missing again, in total it must be equal to 180 degrees, therefore this missing again must be equal to 90 degrees in its size. So in total if you found out that for the level PQVA has 4 right angles, as according to rule 5, any quadrilateral that has 4 right angles must be at least left angle plus a square. So we relate to this quadrilateral PQVA is left angle because it has 4 right angles, but we also know that the opposite sides of left angle are equal to each other. So left angle PQVA, side PQ must be equal to the opposite side AB. But AB is 3, therefore PQ must be also equal to 3 units in itself. Likewise, we have here in quadrilateral PQSV 4 right angles, and therefore it is left angle according to rule 5, but we know that the opposite sides of left angle are equal to each other. So left angle QSCB, side BC must be equal to the opposite side QS, but BC is 3, therefore QS must be also equal to 3 units in its length. Okay, so here, if we focus on this common point, point M, from this common point, M, we have line segment MQ. Line segment MQ bisect side PS. Again, line segment MQ bisect side PS. That is to say, it divides side PS into 2 halves. Each half equals to 3. PQ equals to 3 and QS equals to 3 units in its length. And because of the fact that line segment MQ bisect chord PS in triangle PMS, line segment MQ is defined as a median. Well, because a median of any triangle starts from the vertex of the triangle and ends at the opposite side of the vertex, and it bisects the side, the opposite side. That is to say, the vertex MQ bisects chord PS. That is to say, divides chord PS into 2 halves. Each half equals to 3 units. Okay, so here, in order to find out the length of this median MQ, I presented to you a new rule. Repeat again on the definition of a median. A median in a triangle is a line segment that starts from the vertex of the triangle and ends at the opposite side of the vertex, and it bisects the opposite side. That is to say, it divides the opposite side into 2 halves. This way, in this case, the median MQ divides side PS into 2 halves. Each half equals to 3 units. So in order to find out the length of the median MQ, I presented to you a new formula. I think quickly on the new formula. So what is the length of a median in the triangle? In the drawing we have triangle ABC. Side AB equals to B units in its length, side AC equals to C units in its length, side BC equals to A units in its length. The red line AD is the median of this triangle ABC, because of the fact that AD bisects side BC into 2 halves. The first half is BD and the second half is DC. And BD of course equals to DC. So what is the length of the median AD? According to the new formula, the length of the median AD is equal to 1/2 is divided by 2. It is equal to the square root of 2b squared is the length of side AB plus 2c squared. C is the length of side AC minus A squared. A is the length of this side BC. So in total, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus A squared divided by 2. So we can definitely implement the new rule in our drawing. One put in our drawing, we have the median MQ that bisects side PS in triangle PMS. So in order to find out the length of the median MQ, we'll implement the new formula in our drawing. According to the new formula, the length of the median MQ must be equal to the square root of 2 times MP square plus 2 times MS square minus PS square divided by 2. Okay. Repeat again. According to the new formula, the length of the median MQ is equal to 1 over 2 times the square root of 2 times MP square plus 2 times MS square minus PS square. Again, MQ equals to 1 over 2 times the square root of 2 times MP square plus the square root of, again, 1 over 2 times the square root of 2 MP square plus 2 MS square minus PS square. So MP square is equal to R square plus 25. So we substitute MP square by R square plus 25 plus 2MS square. MS is equal to MS or SM equals to R square plus X square. We substituted MS square by R square plus X square, and we have here minus PS square. PS in total equals to 3 plus 3, that is 6. Therefore PS square equals to 6 squared, that is 36. So PS square in total equals to 36. So in total we found out that MQ equals to 1 over 2 times the square root of 2 times R square plus 25 plus 2 times R square plus X square minus 36. Here we multiply this equation by 2 and finally found out that 2 times MQ equals to the square root of 2 times R square plus 25 plus 2 times R square plus X square minus 46. Here we squared both sides of this equation and finally found out that 2 times MQ squared is 2 squared, that is 4, plus MQ squared, and the square cancels the root, and we left only on the other side of the equation, the square cancels the root, and we left only with 2 times R square plus 25 plus 2 times R square plus X square minus 36. Here we open the brackets, this side of the equation, and finally found out that 4 times MQ square equals to 2 times R square plus 2 times 25, that is 50. Here open the brackets, it is 2R square plus 2X square minus 36. We already found out that according to equation 2, MQ square equals to R square plus 49. Therefore, we substitute MQ square here by R square plus 49. So in total we found out that 4 times R square plus 49 equals to 4R square plus 50 plus 36 plus 2X square. We open the brackets here, so it is 4R square plus 4 times 41 plus 4 times 49 is 196. So in total in this side of the equation we have 4R square plus 196 equals to 4R square, and 50 minus 36 is 14 plus 2X square. Repeat again. And we found out that 4r squared plus 196 equals to 4r squared plus 14 minus 2x squared. Here we have 4r squared on both sides of the equation, so 4r squared will get cancelled, and left only in this side of the equation we have 196. This is equals to 14 plus 2x squared. Here we subtract 14 from this equation. And finally we find out that 196 minus 14 is 182. So 182 equals to 2x squared. Here we divide this equation by 2. And finally we find out that x squared equals to 182 over 2 is 91. So x squared equals to 91. Here we took out of this equation. And finally found out that x equals to the square root of 91. The square root of 91 in terms of numbers is 9.54 units. So in total we found out that the length of this tangent MF is equals to x, or the length of x is either equals to the square root of 91 units, so in terms of numbers, the length of x is 9.54 units. Okay, thank you very much.